This is Aerodynamics podcast number 42, and today we're talking about using body kits to make cars more aerodynamic. And today we have a very special guest, Scott Beeton. He's an aerodynamicist at a company called Adro, and they specialize in doing this. Thanks for coming on, Scott.
Thank you. Thanks for having me.
So, just for the audience, could you go through your background a little bit, just in aerodynamics, what you've been doing and what you're up to now?
Yep. So my background as an aerodynamicist, I guess, really started at university. I was quite interested in, automotive engineering and started with suspension design. Very quickly worked out that aerodynamics was a pretty major part of, adding performance to a vehicle. And at that point, that's when I sort of pursued the aerodynamics path. So after my undergrad degree, I did a master's degree in race car aerodynamics at Southampton University over in the UK, and then went on to work at Williams Formula One for a couple of years.
So they have a strong CFD program, don't they, in Southampton?
Yeah, very strong in sort of CFD and also wind tunnel testing.
Yeah.
They've got multiple wind tunnels there that have been used in the past by a number of F1 teams.
Yep.
Adrian Newey actually attended Southampton many, many years ago, and that's,
Yeah.
I guess, built up some of their reputation. So, once you actually get into Formula One, you realise that there are a lot of people there that went through Southampton University. So, quite a good place to kick that type of career off.
Yeah. How was your time with F1? How'd you enjoy it?
Oh, it was amazing. Yeah, really, really good. Yeah, lots of resources at your disposal to really try and push the envelope. So it was good, and good to be surrounded by a lot of like-minded people. Where I guess the overall goal was pure performance. So that was good.
Yeah. And then after that, where did you go to?
So after that, I moved back to Australia, and I was working for the Ansys software distributor over here. So did that for a few years, and then started my own consulting business, and have been running that sort of up until I've joined Adro. Doing race car design and development, online training programs, that type of thing.
Yeah. So what does Adro do? Like just the nitty gritty of it?
So that company, or the company that I'm now involved with, they are currently making body kits, but they've got some pretty big plans for future development and future expansion into, I guess, other aspects of automotive development. But at the moment, they're doing really sort of well-defined body kits for a number of different vehicles.
Yep. And so for a regular car, what are the aerodynamics in general?
So I guess the things that we're looking at on a general road vehicle are really things like drag.
I've got a picture here that I can probably show to help the audience. So this is just a regular car, and you have obviously the front, the back, and then the wheels, the underbody. So just generally speaking, what would be the aerodynamics of this type of car?
Yeah, so generally you've got a high pressure region on the front of the vehicle. You get airflow over and underneath the vehicle, down the sides, and then a wake region behind the vehicle. So as an aerodynamicist, depending on what we're trying to achieve, we're looking for different things. If this was a race car, then you're looking to add more vertical load, more downforce to the vehicle, whilst maintaining or reducing the drag of the vehicle. So the downforce helps you go faster in corners, and reducing drag helps you go faster on the straights, essentially.
And with a Tesla like this, from what I understand, there's quite a lot of lift because of the top curve. So would this be difficult to make a lot of downforce to go through the corners better?
I guess most vehicles all have this sort of top curved edge. So it's something that some vehicles are worse than others, but generally you can get around that with some different work to the front end and the rear end of the car. You can use the underbody of the vehicle to generate a little bit more load and balance that out.
So how would you do that?
So there are features that you can see on this particular photo here, where at the front of the car, there's a small sort of front lip, or front spoiler, as people call it. So you can add that to the vehicle. And what happens there is you get more high pressure on the front of the vehicle, especially this one, without a huge radiator opening at the front. And that high pressure there also helps to push down on top of that front surface. And you also actually get an acceleration of flow coming across and going underneath that front splitter section, which helps to get suction on the underside of that. So you get high pressure pushing down on the top, and then suction sucking down underneath to help pull the front of the car down to the ground.
So in terms of where the load is, it would be mainly on the front of the wheels and for that part, and then the regular suction under the underbody would then pull the entire car down. So you have a bit more load
Yeah,
on the front.
yeah. So you get more loading across that whole front apron section, and then towards the rear of the vehicle, you can add things like a diffuser to help pull the back of the car down in that region.
So how does
Anywhere where you can accelerate the flow
how
really
does the
helps to
diffuser
pull that
work?
down.
How does the diffuser
So
work?
okay, so the diffuser, there's a couple of different ways you can use a diffuser. So the main thing that you're trying to do there is to accelerate the flow at the throat of the diffuser, at the start of the diffuser, and then allow that to regain, I guess, the pressure gradient that is behind the vehicle as it moves along. So you get an acceleration of flow as it goes through that pinch point at the bottom, and then it goes back towards the normal free stream flow velocity at the back of the car.
Near the back wheels.
Yeah, correct. Or just behind the back wheels as it exits from the car. So yeah, you're trying to, I guess, balance what you have on a vehicle. And balance is something that's very important that a lot of people don't talk about. So I guess initially I spoke about drag and downforce as these two critical things. But if a car's unbalanced, then it doesn't feel right to drive. And a driver who doesn't have the right feeling in the car will then, I guess, really struggle to drive it fast because they're not confident in it. Okay. So balance is obviously very important as well.
So in terms of balance, there's all front first, back, and left first, right?
Yeah, left first, right is a little bit different unless you're doing like a stock car racing or something where they just go around in circles. Left to right is usually pretty consistent on these vehicles because they're essentially a mirror image of each other from left to right. It's only when you get cars that are sort of skewed slightly in their bodywork that you need to look into that a bit more.
Okay, so the suspension does a good job in terms of keeping the car fairly level with a driver in there and no passenger.
Yeah, so the job of suspension is really to maintain the ride of the vehicle.
Yep.
And then the aerodynamics is really to add additional load to the vehicle.
Yep.
So for a lot of the speeds that a road vehicle will be running at, the aerodynamics won't have a huge impact on it in terms of downforce and adding cornering potential.
Yep.
You really need to be pushing the limit of a vehicle to get to that point where you can actually feel that difference.
Okay, so there's for the viewers at home, there's generally a point where the drag of a vehicle overcomes the rolling resistance of a vehicle. So up until about, the rule of thumb is about 60, 70 kilometers per hour. The rolling resistance of a vehicle result in more resistive force than the aerodynamics. But then past that point, the aerodynamics will kick in and you get more resistive force due to that.
Correct,
so on a straight, and if you're just going along, on a nice speed, then the aerodynamics starts to kick in and be very important. But around the corners, you're saying that the car isn't moving fast enough for aerodynamics to be that important.
Yeah, so if you were on, I guess, Australian roads running at the speed limit on a highway or something, then your aerodynamics are not really going to kick in. The downforce that you're generating on the vehicle isn't really the limiting factor on the cornering performance of the car. You'll still be within the realm of tyres and suspension setup. But once you take that car to a racetrack and you are cornering at much higher speeds, that's when the aerodynamics can have a big impact.
I've seen some people, they go around corners very quickly. It's almost dangerous, but they seem to enjoy it on regular roads.
Yeah.
So on a vehicle, what is the most draggy part? Like what's the worst part for a vehicle?
The worst part really is the vehicle itself. It comes down to the size of the vehicle, what we call the frontal area of the vehicle. So if you have a vehicle that has a very small frontal area, so a smaller vehicle, obviously it's trying to punch a smaller hole through the air, so it has a smaller wake behind the vehicle. So the bigger a vehicle is, the more drag it's going to create purely by the shape of the vehicle. So the other thing, I guess, the next biggest factor is the shape of the vehicle. So the size is one, and then you've got the shape. So a vehicle that is shaped more like a teardrop and has like a very long sort of decreasing angle on the back and elongated out, that's going to allow that air that's pushed around that big shape at the start to actually combine behind the vehicle and not leave as big a hole in the air.
So obviously for F1 though, they have like the exact opposite shape kind of thing. It's almost like a reverse teardrop with a flat bottom.
Correct. Yeah.
But that's
Yeah.
obviously for
So
downforce a lot.
yeah. So I guess a Formula One vehicle is running at very high velocities around a racetrack, and they're trying to maximize the speed of the vehicle at every point on the track. So you can run some lap simulation software, and you very quickly understand that if we can go faster in the corners, we'll ultimately go much faster around the whole track.
Yep.
So they build if you take a drag car onto a racetrack and try and turn corners, it'll go really fast down the straights and then struggle to get around the corner, and then go really fast on the next straight, struggle to get around the next corner. So I guess they're built for different things. The Formula One car is built to be, I guess, the fastest around a track in all places. So we do lap simulation.
It's like cutting off its strengths and weaknesses and averaging it out so you can get a better performance overall.
Yeah, absolutely. Yeah, so every track has its own, I guess, requirements in terms of drag and downforce, its own efficiency, I guess, optimum efficiency. And if you can maximize your efficiency and drive it to that level, then you can go very fast around that track. If you have more drag than you need to for that particular track, you'll be slower on the straights, but faster in the corners, but overall you'll actually be slower.
Yeah.
So we fine tune depending on the track to make sure that we've got the optimum there, and we can be as quick as we can be.
So bringing this back to regular cars and Adro or Adro, so in terms of body kits, how does that affect, obviously the looks, it looks much cooler, but in terms of aerodynamics, how does that affect the vehicle's aerodynamics?
Yeah, so it can affect the vehicle's downforce performance if the cars are driven on the track at speed. Ultimately, what we're trying to do at Adro is ensure that when we add a body kit to a vehicle, that we're not hurting the drag of the vehicle. So when you are driving along a highway at normal speeds, you've got something that looks amazing. You can then take it to the racetrack and get the additional performance out of it, but it's not hurting you while you're on the road in everyday use.
And what are some of the body kit things that you do to like a car like this to make it more aerodynamic?
Yeah, so it really depends on what avenue we're chasing. And this is where I guess my background has always been in terms of performance, whereas other people within our business, their focus has always been on design. So we've got a good balance now of different people within the business to do that.
There's a quintessential thing in OEMs where like the aerodynamicists want to make a car look something like more aerodynamic, and then the designer's like, no, that's terrible, we can't do that, and often the designer wins out. But in terms of body kits, at least you can have a better balance there. Yeah.
No, we can have, and we have had some good conversations around, I guess, vehicle design versus aerodynamic performance. And so far it's been quite good. We've made some changes to different things, different design concepts that we've had. We've incorporated a few more aerodynamic elements to reduce the drag and maintain, I guess, the look and feel of the vehicle that the designer was intending, which has been quite good.
And what are some of these differences that you've made, some tweaks?
So some of the differences have been profiles and geometry of, I guess, this front splitter assembly that I've been talking about, and also rear wing profiles. So you'll find that a lot of body kit manufacturers will just use a random off-the-shelf wing profile. That's even if they do use a wing profile. Some of them just use a big oval shape. So
what are some of the common wing profiles that they use? Like just a NACA 00? Is it cambered, or is it just a regular thick?
Some are cambered, some are just a normal thick NACA profile, symmetric profile. We've used a profile, a modified version of a profile that I developed quite a while ago, which is a high lift, low drag profile. We've incorporated that into our designs from now on, essentially.
What's the thickness and camber of that airfoil?
It's something that I probably don't want to disclose at this point. It's a proprietary airfoil that I've developed prior to being with Adro. But we're sort of working with that one now.
Yeah. So how does the performance of a rear wing that you've developed specifically for this differ to a off-the-shelf wing that's been developed 100 years ago?
Yeah, so I think the difference here is that we're looking at getting something that maintains attached flow. We're not introducing massive separation. We're running at angles that are actually realistic for the shape of a vehicle. The particular one I'm talking about, we've sort of designed that around a specific vehicle to make sure that it works for that vehicle. It'll be quite good for a range of vehicles, though, I should say. And I think the difference really is if you look at some of the other wings that you can buy off the shelf, the angles of attack that they get you to run, you'll end up with masses of separation behind the wing. So you're essentially just adding drag.
Yeah.
Like people might think it looks cool or looks racy, but there's actually no performance there. The only thing you're actually doing is spending money on a wing and spending money on more fuel.
So
in other words, getting any other benefit.
In other words, you're just spending time in the stall range, and that's no good for anything.
Correct. Yeah.
So, and I just thought then, like with a regular wing or any wing in general, when you put it on the back of a car, so on the boot or the trunk, you're now there's this very small distance between the suction surface, or the undersurface in this case, and the boot. So it's going to have a very strong Venturi effect, even more than a regular application. So that's going to change the aerodynamics of a wing.
Yeah, that's true. And the other thing that happens there is that you're generating that high velocity flow through that small gap, which means you're generating suction obviously on the underside of the wing, but you're also generating suction on the top of the boot. So the forces sort of cancel each other out unless you can move it a little bit further away or overhang the rear of the boot a little bit. So there's a lot of different design features that you need to consider when you're designing a wing for a vehicle.
Yeah, and with the wheels, I know that the wheels are a big drag producer. Is there anything that you can do in terms of a body kit or just in general to make wheels more aerodynamic?
Yeah, so rotating wheels have always been a big problem. I guess on a road vehicle, they're not as big a problem as in Formula One, where they're out there in the airstream doing all kinds of weird things.
You also need a lot of cooling flow, so they need to be very open as well. So go ahead. Sorry.
So with the wheels, I guess one of the major things is at the bottom around the wheel. If you think of a wheel driving through water, you'll end up with water, I guess, moving around the side of the wheels. And if you do that fast enough, you end up with vortices that rotate down around the sides of the wheels. So with some changes to the airflow around that, you can help to reduce the drag of the vehicle, or at least control where those vortices go and what happens down the side of the vehicle. So subtle features on the side of a front spoiler or front lip can help with that.
So, and where do these vortices around the contact patch end up going? So the front one, does that impact the rear one often, or does it usually steer clear of that?
Yeah, it would usually steer clear of that. Generally, it would actually end up getting pushed inboard, but it depends on the vehicle. A lot of the vehicles I've worked on recently for time attack and whatnot we produce very large vortices off these wings off the side of the car. So you end up with a lot of flow rotating back in through underneath in front of the rear wheel to then help drive the diffuser flow as well. So, every vehicle is a little bit different in the way that it works, but typically it'll run down the side of the car. Depending on what's behind the vehicle, if you have a wing or a big diffuser, it may get pulled through before the rear wheel, or it may still sit outboard of that.
Okay. And so for a user, so like a driver of a vehicle with a body kit, such as Adros or Adros, how would that feel on a racetrack when they were to use it compared to not having one?
Yes, on a racetrack, if you're generating additional load, what it will essentially do, it shouldn't feel too much different to what they currently have, unless the balance of the initial car was, I guess, not so great. But the idea is that at speed, you're maintaining a balanced vehicle so that you really are just increasing your cornering speed. So it's that old catch-22 with performance cars versus normal cars. Whatever car you're driving, if you're driving it on the limit, you're still getting that same feel of, I'm right on the limit of this car's performance. And I guess that's that fun zone that people look for. So I guess it just allows you to do that at a quicker speed, essentially. Your lap times can come down, but you'll still feel the same, essentially.
So you want to come as close to danger as possible, but not cross the edge.
Don't cross the line.
Okay, so this is coming to sort of the end part of the podcast. I mentioned earlier that I have a little game where I'm going to show you 3 cars, and you can tell me some general ideas of how to make them more aerodynamic with body kits. This is the first one. So what would you do here to make this vehicle more aerodynamic?
So I guess it depends on what you're targeting. If you're targeting a reduction in drag, then there's a few things you can do. Being a Tesla, I guess it's quite good. They've already got a very flat underbody to reduce drag. So this car here, in terms of making it more aerodynamic, I don't know if there would be much that you would do, or it would be probably more of a styling type of thing.
Okay, so Teslas are usually pretty good to begin with.
They're fairly good to start with, yeah. I guess it's more of a styling thing for the Teslas. If people want to, I guess, get a bit more of a sportier look, probably more to what a Tesla, I guess, to what the purists probably think a Tesla should look like.
Yeah. Okay, so moving on to the next car, this vehicle here, so they're both the same, I'm quite sure, a Corvette Z06. Yep. And we have the front and the back, you can see. So what would you do here?
So again, it depends on what you're looking for. These, I guess, being gumball rally cars, or at least one of these, if they're looking for additional performance on those vehicles, I would be considering a bigger front lip there to add additional front downforce to the car.
Okay, so on the splitter plate kind of area you're talking about.
Yeah. So a bigger extension there can help to add more vertical load to that front section, and then to balance that.
Why is that?
Sorry. So I guess the further out you come, the more surface area you have for that high pressure to act on. But obviously there is a limit. You can't go 6 feet out in front. That just doesn't work. You still need to have that sort of high pressure to build up on the front of the vehicle and then push down. So I guess probably the biggest one that we've ever worked with was, let's just say a safe number for a full-blown race car would be sort of 200 mil max. A lot of categories only allow 100 mil. So they could easily extend that out further on that particular vehicle. Down the side of the vehicle, there's no sort of side skirts or similar sort of feature there where you can add a little bit more vertical load and control the flow down the side of the car.
Okay, so extending a horizontal surface on this side will help you.
Correct, yeah. And there's different shapes and geometries you can put there to get the airflow to do certain things. You can try and maintain airflow on top, or you can try and help roll airflow underneath the car. It looks like, well, obviously the yellow one doesn't have any canards on the front of the vehicle. It looks like the white car may.
By canards, which part are you referring to, sir?
So just underneath the headlight on the yellow vehicle, in that sort of open area there, some vehicles you'll see will have those small winglet shapes. So I think it does look like there's one potentially on the front of the white car there. So that can help to add a little bit more front load and also control the airflow down the side of the wheel, which can then also help extract airflow out from that wheel well to reduce lift in that area as well. So there's a few things there at the front of the car, but then once you've modified the front of the car, you really need to make sure that you're also modifying the back of the car. We probably see the opposite issue on a lot of vehicles here in Australia, where people have a car and they go and put the biggest rear wing they can find on the back off eBay, and then they wonder why the car doesn't handle very well. It's like, well, you've just upset the balance of the vehicle considerably. So you've added all this rear load, and now your car, every time you're in a high-speed corner, the car will just understeer. So I guess in this example here, we've spoken about changing a lot of things in the front end of the vehicle. So to balance that, you would be looking at things like a flat floor and a diffuser geometry to really try and accelerate the flow under the car.
So how does a flat surface differ to like an exposed surface? What would that do to the flow?
So the flat surface really, it just helps to maintain a smooth flow through that region. If you imagine the top of the vehicle looked as terrible as the underside of the vehicle, it becomes pretty obvious that the air flowing over that surface is going to be pretty chopped up and turbulent, and that adds drag, it slows the air down. So if we can maintain the air speed, then that's when you get better performance. So having the air flow faster through underneath the car helps the front splitter actually work harder because you're getting more air rushing past that surface. Then it also helps the rear diffuser work harder as well. And then obviously a rear wing on the back of that white car as well to help fine tune the balance.
Yep.
So the rear wing is usually a tuning tool. It obviously has the biggest impact on drag because it sits up in the airstream by itself. And if you run it at a very high angle, you'll essentially separate the flow behind that. That'd be quite terrible. So you want to run as low an angle as you can to get the balance of the vehicle right.
Okay. And then the third vehicle I mentioned is a wildcard one. You may not have expected this one. So how would you make this more aerodynamic?
That's an interesting one. Now, I guess it's one of these things. They don't typically run at a huge speed, but they do run at fairly high speeds.
Yeah, they can get up to 100 k's.
Yeah, so if someone was chasing you down, one of the things you wouldn't want to have happen is for this thing to run out of fuel because it's got so much drag. So yeah, there's probably a few things you could do. You could look at, I guess, that whole flat floor scenario underneath the tank. The top of it looks horrendous, probably like what I was talking about before. Whether there's ways to duct air from the high pressure surface on the front out to the back to reduce the size of the wake. That's something I've done on Dakar race vehicles before. So that type of thing could help to reduce the drag and maybe get you a few extra Ks. They might make it to safety.
and maybe shielding the wheels, do you think?
Yeah, shielding off the wheels. Yep. Yeah, that sort of thing would be good as well. Yeah, anywhere where you can reduce that turbulence going past the vehicle. Teardrop shaped, I guess, round sections there on the front. There's a lot happening there. Plenty of scope. So it'll be a good project.
Okay, so let's bring it to the end of the podcast. Is there anything else that you wanted to say in terms of what you've been doing or what Adro does? Where can we find you and Adro?
Yeah, so you can find Adro at adro.com, adro.com. I guess we're constantly adding vehicles. We've got a pretty good process in place now. We're 3D scanning vehicles and then reverse engineering all of those surfaces to then build components that will fit to, I guess, the factory mounts where possible. So we've had a lot of success with people getting our body kits and they just love them because they just fit straight away. Everything fits perfectly. We haven't taken molds and then done the dodgy and cut and shut things to make it work. It's all reverse engineered. We've got proper tooling made up and manufacturing these components to the highest quality. So there's different options for different vehicles and we're constantly adding more vehicles.
And where can the viewers find you?
They can find me through adro.com. There'll be sections there about me, or they can email me directly at scott@adro.com.
Okay, sounds good. Well, thanks for coming onto the podcast. And
thank you very much. Appreciate it.
Yeah, and I enjoyed it, and I'm sure the viewers enjoyed it, and you're welcome back anytime you like. Thank you.
Fantastic. Thank you.
So that's it for this podcast. Make sure to like and subscribe. Check out other podcasts. Check out our instrumentation we do. Check out the courses we put on. Check out the International Aerodynamics Conference. It's a conference we put on every year. Links in the description. Peace out, amigos.